Hello everyone. Today I'm going to walk you through a business use case where we built a predictive export clearance system for a global snack food exporter. This project solves a major operational bottleneck, manual and inconsistent export authorization. So before going into deep into the project, let us understand who's our client. Our client is one of the leading exporters in the snack food industry, distributing high variation products globally, shipping high variation products to multiple countries, basically. They deal with items like chips, biscuits, popcorn, chocolates, hundred of SKUs, each with different packet sizes, weights, and compliance rules. Right? Let us see what is the problem that we are facing, right? Manual and inconsistent export authorization due to complex snack variants, region specific compliance rules, and MOQ deviations, causing dispatch delays and operational inefficiencies. The problem was that export authorization was done manually, right? Now, why is this challenge is appearing, right? Each country has different compliance rules. Each product has different packet sizes, weights, and ingredients. Approvals depend on MOQ deviations, lead times, customer history, and product type. Manual checking caused delays, inconsistencies, and errors as well. Ultimately, this led to dispatch delays, increased inventory holding, high demurrage cost, and then cost dissatisfaction, poor planning, and then forecasting as well. So, what is our business objective? That is to maximize approval accuracy, that is, ensure the right decisions are made consistently, maximize compliance efficiency as well. That is, reduce time spent on approvals and minimize the manual effort. Let us see what is the business constraint that we have, right? That is to minimize the load deviation, right? This means the system must avoid approving orders that exceed weight limits or violate packaging constraints. What are the different success criteria that we have? Let us see that, right? Success criteria is basically is used to measure the goodness of the entire result, entire service that we provide, right? We measured the success using three metrics mainly. One is business, economic, and machine learning success criteria. Let us understand the business success criteria. Reduce order authorization turnaround time by 60%. That is faster approvals, smoother operations, which will lead to timely dispatch ultimately. Economic success criteria. Reduce inventory holding and demurrage cost by 15%. With accurate predictions, the warehouse avoids unnecessary delays. Machine learning success criteria, that is, achieve more than 98% of accuracy in predicting authorization outcomes, right? Achieve more than 98% accuracy in predicting whether an order will be approved, pending, or unknown. This high accuracy ensures trust in the model's decision. So, this is something with respect to business problem, objective, and constraint, along with the success criteria. Now, let us understand more about this. Let us look into something called as data description, right? Basically, we will understand, right, what is that data that we use to build the predictive system, right? So we use date, right, when that particular transaction happened, serial number, that is which identifies type of the transaction, document number, unique ID for the tracking purpose, create new user, employee who created the entry, right, customer account name, customer making the purchase information here, customer PO number, purchase order identifier, authorization status, that is the target variable, approved, pending, or unknown, and then item name, name of the snack item. item category, that is chips, chocolate, popcorn, what it is. Okay. And then item packet size per gram. Okay. Weight per packet. Then item net weight, total kg ordered. Okay. Quantity, that is number of units ordered. Rate, price per unit. Okay. So these fields help machine learning system learn the patterns which customers frequently get approvals, which items have strict compliance, which packet sizes cause delays, how quantity and weight influence authorization. All these information can be analyzed with the help of the data. Let us look into the basic architecture which we followed to, yeah, uh, let us look into the full pipeline for how the system works over here. The first will be the business and data understanding. We first studied the business rules, compliance parameters, and stakeholder pain points, right? Once that is done, our next focus was on to data collection and EDA as well. We gathered historical transaction data and did exploratory data analysis to understand the pattern, approvals were reject, which approvals were rejected, monthly clearance trends, how product category affects compliance, lead time versus clearance behavior. All these things are being understood over here. Next comes the data pre-processing. This is the most important part. That is nothing but the data cleaning process, like handling the missing values, fixed incorrect packet weights, probably standardized item categories, data transformation, that is convert textual information into numeric and create lead time buckets as well, data integration, merge the transactions, right? Customer master data and then product master data. All these things need to be merged. Feature engineering, that is total shipment weight, deviation from standard MOQ, high risk country flags, all these things. Of course, the feature selection, right? Keep only the most meaningful inputs. Train and test split to make sure our model generalizes well. Once this is done, our next part would be model building, modeling and the evaluation part, right? We tested multiple algorithms, random forest, XGBoost, decision trees, right? The best performing model achieved 98 percentage plus accuracy. We evaluated accuracy, precision, recall, confusion matrix, and ROC curves as well. Then the final stage would be the deployment, not the final. Uh, Once satisfied, we deployed the model using Streamlit. It allows the user to upload an Excel file and instantly get the predictions. Then the final stage would be the monitoring. We monitor prediction accuracy, delete approvals, model drift, user log, etc. Dashboard is also built using Power BI. Let us look into the dashboard. How does it looks like, or what information that we can gain? So the dashboard helps management understand real-time export performance. Like for example, total export 18,000, average predicted clearance that is minus 5.98. All these things could be analyzed over here. Average actual clearance minus 36.68, on-time clearance rate 0.59, total export value 23.36 million, and delay rate 0.41, right? Negative clearance values mean orders are clearing earlier than scheduled. Positive means they are delayed. So these graphs over here, actual clearance and predicted by month, right? But it shows model reliability over months. And then orders by country and authorization state. This which countries have more pending or unknown approvals, and then total export by lead time and actual clearance time, right? Longer lead times generally reduces the delays. And then sum of quantity by item category, which product types dominate export, for example, generic, regular, popcorn, right? And then pie chart, which speaks about total orders by status, the immediate snapshot for of approval health probably. And then this bar chart over here, it speaks about quantity by country, helps understand export volume per region. right? So we can filter as well these dashboard based on the country name, authorization status, and item category as well, right? Item category as well. Earlier, staff would manually check batch by batch. Now, in seconds, hundreds of orders get predicted. This saves time, cost, and ensures the consistency as well. Okay. So when it comes to the user interface, this is the interface the operations team uses, right? It's a predict page basically. User uploads a CSV or Excel file. System reads multiple columns automatically. Real-time validation shows if the file was uploaded successfully or not. Highlights any missing data. Then you will be able to see the model output as well, right? Each row gets predicted authorization status. Users can download results, and then navigation panel as well, where um, you'll be able to see predict settings, about section, language selection, and you have a dark mode as well, right? Dark mode as well. So we solved a manual error-prone approval processing using machine learning, achieved 98% prediction accuracy, built dashboards for performance monitoring, developed an easy-to-use Streamlit UI. So the business saved time, reduced costs, and improved operational efficiency as well. So the project demonstrate how decision AI can streamline complex export workflows and support data-driven decision making. So, yeah, what we offer, other than what I've explained, challenging real-time projects that limit, push you to your limits, learning of all phases of project methodology, right? You will go through multiple phases of learning about different tools used in the industry like Python, Power BI, SQL, cloud platform, etc. Work on research paper that published in international journals, access to various free tools to enhance your learning, like Mind Map, Architecture Assistant, Resume Optimization Hub, Animated Learning. Right? If you want to reach out to us, you can contact through the toll-free number. At the same time, you can drop us a mail or you can visit our website as well. Okay. So this is something with respect to the brief explanation on the use case that we have solved. Thank you, everyone.